And we'll continue. So, sir is with us. Now we continue.
Thank you, Manmohan. Today we'll be talking about demand response analysis of smart grid. So there's a small difference and similarity between demand side management and demand response activities. Now, what happens, in case of demand side management, most of the utilities put their effort to make sure that the peak energy requirement is being reduced or the deficit is being minimized. However, in case of demand response program, the consumers like you and me can participate in the process of reducing the energy deficit. Okay, so it is two-way. The information is not coming from the utility that to shift you from one point to other so that the peak can be reduced. It is otherwise also, we also participate in a manner so that the national peak is moving from one point to other. So the first program which is coming from utility side is more or less known as demand side management program. However, when the consumers participate in peak shifting as well as load shifting programs, then it is known as demand response program. Okay.
So, demand response includes demand side management basically. It's a broader.
No, because demand response actually I voluntarily participate in a mechanism that helps reduction of energy deficit. Okay, so means for example, there is a scheme of actually pricing energy price, the cheaper energy at a particular point, where I feel attracted and participate. But the idea in case of demand side management, it is the target to the alteration of the consumer's demand profile in time as well as shape. So I'll give you the DSM and demand response. If you see demand response activity and DSM activities, the final objective is same, but the initiation is comes through your consumers or from the utilities will decide what type of program it is. Okay, but both have the same intention to reduce the peak energy deficit and reducing the peak requirement. Okay, means the utility, one of the key objective of smart grid is to make the power sector energy efficient by matching the load variation along with the volatility of the renewable generation by utilizing the scalable information processing strategies. The idea of demand side management DSM includes all activities which target to the alteration of the consumer's demand profile in time and or shape to make it match the supply, while aiming at the efficient incorporation of renewable energy sources. Now, one of the main DSM activity is going to be demand response. So DSM has actually many approaches, and demand response is one of them, where it motivates the consumers to be part of the load shifting program. Now, what is demand response in that case? Because demand side management program, in case of demand side management, we have already learned the definition. Let us understand what is DR, demand response. Demand response, it is a tariff or a program established to motivate changes in electric use by end user consumers in response to changes in the price of electricity over time. Means they can change the consumer behavior by giving different pricing mechanism or to give incentive payments designed to induce lower electricity use at a time of high market price or when the grid is jeopardized. Means you have a system. When the system is in trouble, they will encourage you not to use electricity by giving some price incentives. The main difference between DSM and DR DSM and demand response DSM, after all both are DSM, is performed only at utility level, okay, Demand side management is taken care at utility level, and DRM is performed at both utility as well as consumer level separately and or together to achieve the low peak load curve and reduced electricity cost. What I wanted to highlight here, when you talk about demand side management program, it is the utility who takes lot of interest in shifting the load. Okay.
Is it forcefully or maybe they manage in some way that this loads
I mean, for an example, the government will bring out a policy uh, that the lights, okay, will be switched off alternatively in the streets across the country to reduce the evening peak. For an example, instead of having too much of brightness, let us reduce the brightness or switch off one light alternatively if you have an automatic program. Just mute it. Okay. So what we realized that, okay, I was just giving an example where I stop. Let's say the utility decides they have a distribution system and lightning happen to be 30 to 35% of your electricity load, okay? And those lights actually I can make it automated. And today perhaps most of the Bangalore, Mumbai, Delhi, Noida, Hyderabad, the street lights are automatically controlled. So I may say, let us dim the light, okay, in the midnight, or I may say during peak hours, actually, I can alternately switch it on. During the area where there is no traffic, there could be many highways, there is no traffic, so that can be managed. So that is the interest of the utility. So utility takes some step or mechanism through which the peak actually got reduced. That is one way of doing it. But giving me an incentive with less price during an off-peak hour to charge my electric car is known as demand response. Okay, so DSM you understood? So, and also the farmers, what they do, they give some electricity supply during 4 to 6 a.m., only few corridors for pumping their water, for an example. So that, they are not going to switch on their pumps during peak hours. So these are the DSM programs. Or even in a lighter note, people are providing, the government is providing LED bulbs with cheaper price or low cost or even sometimes free of cost. So what they have done actually, instead of putting 100 watt, now I'm putting 12 watt. And because of which, I'm actually reducing my electric bill. So the replacement of high rated bulb by a low rated LED bulb with equal illumination is a DSM program, isn't it? But telling me not to use the air condition during evening hours is a demand response by some price incentive. So that means they are helping me to get attracted with a scheme and operate your devices in such a manner so that the electricity consumption will be very, very less. Okay? Good. Uh, is it fine? So this is the difference between demand response and DSM. Now, moving to main aims of the demand response analysis. First of all, actually minimization of total energy consumption. So, first of all, how to reduce the consumption pattern and how to reduce the total power generation requirement and promote the idea of moving to renewable energy side and also reduce the line overloading so that we can delay the replacement of the lines. Now, this is how actually the demand response program looked like. One more interesting thing I like to tell you, very important. Now, there is a concept called aggregator. So, what is the role of the aggregator? Aggregator will come to you and tell Dr. Manmohan, I will give you electricity to run your industry, uh, subject to with a very 50% of the cost, subject to you work during night time instead of daytime. All right. So he will get all the schemes and then contract with a generating company to give cheaper power with 25% of the cost for a particular off-peak hour. And then he makes that 25% profit. So he doesn't carry an electricity, but he can make money by connecting people with the generation company with a restriction what to use and when to use. So what I wanted to highlight, those aggregators basically take the input from the residential side, commercial side, and industrial sides. So we will be reaching to the aggregator through a scheme, and that aggregator will be dealing with huge power companies and getting the electricity through bidding, making this negotiation and clubbing together. That means evening users will be 1 million and there are 10 million units of energy required during that particular hour, that block, and he will negotiate with a particular company. That can you give me that price with a lower price? So what has happened actually, that aggregator forced all the consumers to be part of this demand reduction program, and that is known as demand response. Means all the residential people, commercial people, they all participate in a event. I think you'll be very happy to know that there was a time in United States because heating became a very, very, common requirement in Western country, and that itself is a big load. Everyone need heating. So what they do, that heating system, because you may participate in a demand response program where you can say, I may compromise my heating system by few degrees Celsius, subject to the price is going to be bit less. Instead of living in a pleasant environment of, let's say, 22, I'm ready to live with 20. And similarly, the air conditioning loads, instead of with 16, I'm ready to live with 18. But air condition actually you cannot do because that is in your own operation. But those heating facility which are centralized, few customers, nodal points can be controlled with a limited price. So if you say that I agree to a controllable heating requirement supply, heat requirement supply, then my price will be reduced by 50%. And few people may say, no, 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 I will not compromise my heating. It has to be there 24 hours with my own comfort, with my own range, and I will pay the full one per unit of rupees X. You got my point? So this is how actually the demand response activity means engaging your consumers to actively participate by reducing the peak energy or the total energy consumption with some monetary benefit or incentive is known as demand response.
One question.
Yeah, please.
Do the aggregator have any authority to deal with power without any regulatory body from Government of India? If so, any licensing body is there?
No, no. Aggregator is basically need to be authorized person. It is not anyone can do it. Probably the aggregator could be a distributor company, could be an agent, but they are not like silent players. They are known officially. They are authorized people to do this business. In a lighter note, what I say that they without buying, without selling physical electricity blocks, still they can make money. So they are basically power brokers. They are power brokers.
Limited companies.
But
Companies.
yeah. They are actually authorized companies because energy broker companies. Now the demand response process, if you see, the ISO determines the preferred. So demand side aggregator is.
Practically now.
Yeah. It is there. Especially in Western world, it is very common. But in India, there are few. And even today, we have actually in India aggregators. But they are actually handling few small scale industries basically. They get power for industries. Okay. But they're not very significant in this country. Right? But in European market and North America company, they are actually very, very active. Okay, next please. ISO determines the preferred demand volumes and time during that is offered. Aggregator receives the load data from the ISO. Aggregator select the consumer for their participation into the DR program depending on their availability. Accounting the number of interested customers agree with the proposed DR, the aggregator optimizes the total demand. And finally, new load demand data is reported to ISO and local distribution operators. This is how actually the whole process operates. Now, what do you mean by DR applicability on different consumers? It is specific to industrial consumers. High energy consumers with peak load and few megawatt load have critical temporal dependencies and must be scheduled with the high time resistance. Okay, the DR program should capable to monitor and control the loads in milliseconds time scale. Okay, whenever there is a huge peak, it should be stopped in milliseconds. Furthermore, security issues are particularly important is the load profiles of the load shapes is highly confidential and computation sensitive. Now, in case of actually commercial consumers, main power consuming equipments are heating, ventilation, air conditioning, that is HVAC, and heating, ventilation, and air conditioning, lighting systems, and electronics devices. The reduction of the power consumption. For an example, I do not know today if you go to any star hotel, I mean, you will have a dim light, but as you walk, the corridor will be brighter and brighter. Sensor-based actually lighting. Why do we?
Hierarchy corridor also.
Yeah, we
First
have.
floor, first floor.
And when today it is there, actually, most of the tube lights are of that.
That time also.
Yeah, that time also. Yeah, 10, 15 years back, we have done that. Because, especially my office, that corridor, nobody sits excluding me. Only when I go, actually, the light will glow. Otherwise, it won't. So, that is one interesting thing, actually, I have found. Okay, so probably this kind of schemes can easily be done, starting from heating control, AC control, light control. They can be, seriously participating in this mechanism. So building energy consumption behavior through price elasticity of the power demand. So they can say there are few mandatory lightning mechanism. Others they can do depending upon the price signals. Now, residential, is very interesting. We have actually HEMS system, by home energy management system, whereas I was talking yesterday that all your devices are connected. The smart meter will get a signal from the main utility about the price signal, and based on which it will operate all my devices so that the peak can be controlled. So this is how actually all the three things can be done. Now, DR communication requirements, because there are so many devices, so many components. So quality of service is important, interoperability is important, scalability and flexibility, and finally, security. When you make the devices digital control, it may so happen, someone sitting at a distance can switch off, make your whole hotel dark. You have, auto control, but someone can interfere and completely make your hotel dark or the city dark. So that is what the security reason one has to be extremely careful. And there are different optimization targets. You can, first of all, try to minimize the electricity cost for a industry, for a commercial location, for residents. You can also maximize the social welfare. What do you mean by maximization of social welfare? I think one day I talked about it, but let me repeat it. When you carry out the bidding process, you get some money from the generators, consumers, and you pay some money to the generators. When they will be, given an opportunity to offer their bids. So when you match the load and generation, you will see the characteristic through which the consumers pay and the characteristic which the generator receive the payment. Means you first encourage the consumer who is paying the maximum, and then the second consumer who is paying the less and less and less. So the characteristic will be stepwise coming down, 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 down. Okay. Now generator, you will pay to the least. First, actually, who were offering the less cost, you will be paying them. Am I right? And then you will be paying to the next highest, next highest, next highest. So the generation cost will come like this, going step by up, and this fellow is coming down, and both of them will match. You will see there is an interconnection. There will be interconnection or intersect between two bidding characteristic of generators and consumers. So the area means this is what I'm receiving and this is what I'm paying. So the scale, which is the difference between two characteristics, is nothing but the benefit that I gain. But being a non-profit organization, ISO or social welfare organizations, that money need to be spent for other benefits, and that is known as social welfare. So we have to optimize the social welfare cost. Means, what do you mean by optimization? Means I will see to that how cheaply I can buy energy and how costly I can sell energy. That's what I can make more money and I can return back to the society. Minimization of both electricity cost and aggregator power consumption, both the maximization of social welfare and minimization of aggregated power consumptions. Classification of DR programs. DR based on control strategy, DR based on price, DR based on load, centralized control, decentralized control, all right? And then we have dynamic price based control, incentive and penalty based control, task related DR and energy related DR. So there are many opportunities which are available with us for DR programs. So this is what we do. As you could see that, there is energy flow from aggregator to the houses, and there is a distribution substation which talk to the aggregator and who manage thousands of house or 2,000 of house, when to use, how to use, what is their price elasticity mechanism, and how it can be controlled. Because the aggregator only can understand your mind better than anybody else. And similarly, we have decentralized, this is centralized control. We have a decentralized control where everyone, themselves try to optimize their energy requirement. Now, DR based on control strategies, centralized control, decentralized control. So, centralized control means response decisions for load activation are only tackled by the power utility. Overall load profile improvement by considering network security is done. Users' privacy is violated due to complete monopoly of utility. Utility only get to know about the net consumption of the consumers. Utility designs price signals to influence its users. Users schedule loads on its own depending on the revised price signals. Now, there are two different demand response activities based on price. So, one we call it dynamic pricing based demand response, means you can have the variable price around the day, and depending upon the price at a given point of time, people can act. Okay, or we can say if you behave particularly, then an incentive will be given or a penalty will be given. So, when you say dynamic pricing, that is basically offers customers time varying prices that are defined based on the cost of electricity in different time periods. And these prices are designed according to the load level of the entire system. Now, moving to incentive or penalty based DR offers fixed or time varying incentives or penalties to customers that obeys or violates DR contract during periods of system stress. So dynamic pricing, they are of different type. One is TOU, very popularly known as time of use tariff. Critical peak pricing means you can have a specific price during a particular hour. We can have a peak load pricing and we can have real-time pricing. Okay, means based on the bidding matching mechanism, you can have real-time pricing. Means whatever the market buys for you, you pay that. Okay.
So incentive and penalty is fixed kind of. Dynamic means based upon how much momentarily required.
Because there are two things here. When you say dynamic pricing means it is a variable price.
Not
The price is going to vary 24 hours. But there are different mechanisms to have those variability in your 24 hours period. One is actually every hour or 2 hour, you will have a different price from morning to evening. Or you can have a 4 hour slot, 6 different prices. That is my TOU. Now, critical peak pricing means only when there is a peak, there will be a price, otherwise, rest is constant. Then you have peak load pricing. So you will have multiple peak load. So you will have 2 to 3 peak load slots. And then you have a real time pricing. Real time pricing means it is almost 15 minutes or half an hour or 5 minutes pricing throughout the day, which is very, very critical. Now, what are the tasks related to demand response? Reduction in the peak consumption is achieved by altering the operation time of flexible load within a predefined delay limit. Total energy consumption over the time period remains fixed, but the consumption time is adjusted according to the necessity. Okay, that means you have a device and you say whenever there is energy, I will utilize it. Okay, energy related DR does not alter the operation time of the flexible loads. Rather, it lowers the consumption of some of the appliances at peak demand. Okay, so it is not shifting, but it is reducing its consumption during peak hours. So that is energy related, and this is task related. Good. So coming to a conclusion, successful implementation of demand response program is possible if the users participates into it willingly without compromising with their comfortable lifestyle. Means they participate but don't compromise their lifestyle too much. DR program does not ensure DR program does not ensure a same amount of benefit for all the participating players. That is, some may be incentivized, whereas some can receive penalty. The employment of DR relies on the reliable, robust, and secure communication systems. Choice of efficient energy price structure is the main key factor to attract the users towards DR programs. All of the above DR scheme should be unbiased. That is, fairness is the basis need for the demand response program. So if you can bring a transparent mechanism, that would be really good for any system. Okay. How many students are there today? Because of Sunday,
34.
34 students. Okay, good. So all right. I think I'm happy that even on Sunday, almost everyone joined this program. It's quite good. So now we'll move to demonstration of solar power generation. So a little bit we are getting into the hardware part. So Manmohan will be, now will be feeling very comfortable and happy with this unit today because it is your area. So demonstration of solar power generation. What we talk actually, when you generate solar power, as you all know, we generate this power in the form of DC, and then we convert to AC and then give to my grid. All right. So we need an inverter to convert the DC power to AC power. So sometimes the conversion happens in one layer and sometimes the conversion happens in two layers. So a solar inverter converts DC power from actually PV panels to the AC power. Now it can operate either in grid connected mode or in islanded mode. Additionally, it has the responsibility to inject high quality current and provide grid support. Now this is what the architecture or the configuration of your single stage inverter control systems. You have PV panels, you have loads, and the control scheme, which is very, very basic and standard control scheme for any PV systems. Now, this is what important to me today. There are two important characteristics that are being considered as important variables. One is IV characteristic and the other is actually PV characteristic. So if I plot IV characteristic and PV characteristic of a solar cell, as you could see that, there is a point which is my maximum power point where VI, okay, V ampere and I ampere happen to be the maximum, okay. And then I can have a PV characteristic for a particular voltage point. You will see the maximum power is being attained. Okay, so that is also known as my maximum power point. That we say maximum power point tracking. That is where actually we operate. So IV characteristic and PV characteristics gives you an idea that how open circuit voltage takes place, how short circuit current takes place, how the maximum power point V ampere and I ampere takes place, as well as maximum power point from the PV characteristic can be obtained. Now, this is how to rig up a DC-DC boost stage, because most of the time, the DC voltage that we produce, or the DC power we have, that cannot directly be injected to AC because, sometimes you need to boost DC to DC and then AC, okay? And that is very commonly being seen. So considering all these challenges, so this is for the structure of your DC-DC boost stage. So we have the solar emulator with us, and then we have an inverter DC link for your power transformer. Now sensing and PWM output. So this is what your architecture, and this is a module basically in case of your RT lab. So this is the structure. So RT lab is basically those who are using RTDS. Okay, they can use RT lab, or they can even use the MATLAB or Simulinks for your actually PWM outputs where you have AC voltages, AC currents, DC voltages, and finally you can have R phase, Y phase, and B phase pulses. Now, sensing the PWM outputs, we can have a bus, and then you can see the R phase, Y phase, and B phase. So first of all, try to understand. You give the signals that R phase and Y phase pulses that you have received in the previous diagram. They can be injected to your Skyper nodes, okay? And then you can have a DC bus, which is my plus or minus 15 bus, 15 volt. Now, there are two different mechanisms for solar inverter configuration. It could be single or dual stage. Single stage is very common for small, size PV inverters mechanism. Our is important for your large size mechanism. So, in case of single stage solar inverter, you have only one conversion stage. PV panels are connected directly across the DC link. However, in case of two stage inverter configuration has two conversion stages. PV panels are connected to DC-DC stage, okay, and conversion losses are quite more, but it is practical. This is your single stage solar inverter control mechanism. You can say MPPT, and then you have DC link voltage control, then you power and AC control, and then DC-DC AC converter. There is a feedback mechanism for your PWM to act upon. Now, when I talk about dual stage solar inverter control, as you could see, the DC-DC stage extracts maximum power from the PV panels based on maximum power transfer theorem. Okay, when you talk about maximum power tracking, or this is based on maximum power transfer theorem. In most of the cases, the DC-DC stage is a boost converter. All right, the DC-AC stage regulates the DC link such that active power is transferred to the grid. Inverters also provide grid support by controlling reactive powers. And this DC-DC converter control you can see, as well as you can see the DC-AC converter control mechanism, and for the dual stage inverter structures. This is what general perspective of a PV panels connected to my grid through different control mechanism, how maximum power can be tracked or extracted from the PV panels. So just basic introduction. Probably when we meet tomorrow, we'll talk more about.
We have video.
Huh?
Video is there.
They will run it actually. So there is a small video for you. We will be happy to run it so that you can appreciate what we are doing. Thank you. Has to ask, can they see the video? Is it visible to them? Who's visible?
Is this video is visible to you? Screen?
Yes, yes, yes. Thank you.
And the video voice is also audible?
Yeah.
Okay.
You can mute my video.
टीवी पे ऑन भी नहीं आ रहा है।
You can see this. We'll do trade it.
करते हैं इसको उधर करते हैं, फिर उसका बाद इसमें जाएगा शेयर इसको वैसे कनेक्ट करके ये वाला सीखा है।
उनको मैसेज कर दीजिए. We are trying to resolve this issue. Please hold on. One. His direct of the three plates on burning in our test. Now, when you focus on the characteristic of the solar cell, maximum power point current. Simulating the PV highly characteristic of the solar cell. Or the maximum power point power to the grid. Not be get deeper. So what we are thinking that because of some small technical issue, we will share the video through Canvas. We will do that, and as well as we will also run it during the next class. Okay, so that we all will be able to have an interaction after the video is being run. Okay, so don't worry. So we stop here today.
Next class tomorrow.
Tomorrow I'll be, actually tomorrow there is no class. We'll announce actually. Tomorrow there is no class. We will announce the next class. We'll announce it.
Tomorrow we will decide.
Tomorrow we'll decide. But tomorrow there is no class for sure.
And then on 10th we will tell them later.
Yeah, we will announce tomorrow about the next class.
Okay, so tomorrow we will not have any class, and we will let you know on WhatsApp for the class on day after tomorrow. As of now, we can schedule it. As of now, we can schedule for 10, then we can cancel like that.
Do it for
10th, परसों के लिए इसमें नहीं होगा तो फिर हम cancel कर देंगे.
Yes, we can make it 11th better. 10th also I'll be.
11th, 12th,
11th I'll be.
11th, 12th, that meeting. That
meeting is there itself. I can do it actually. 11th I can do it because I'll be at least not traveling.
So tomorrow there is no class, and for 10th we will let you know tomorrow evening whether it's there or not. So thank you all. Thank you.